Okay, now I'm going to go over a quick example of how to apply the product rule. So the product rule tells you that if you want to take the derivative of a product, f of x times g of x, then it's going to be the derivative of f of x times g of x plus the derivative of g of x times f of x. And the way I look at this is if you have the derivative of the first times the second, then it's the derivative of the first times the second, leaving it alone, plus the derivative of the second times the first. And I'll go through some examples here in just 1 second. So since I'm flipping over to my tablet, I'm going to turn off my video. Okay, so again, the way I think of this is if I have two functions, first and second, then what the rule is telling me to do is take if I want to take the derivative of the product first times second, then it's the derivative of the first, so I'll do in blue, times the second, you leave the second alone, and then it's plus the derivative of the second times the first, leaving the first alone. So like as an example, let's say that f of x was something like x cubed plus 2. And g of x was something like, I don't know, x squared plus x. Okay, so then here's the derivative of the product. Now, one thing I could do is I could FOIL this out, I could expand it, multiply all the pieces and then take the derivative piece by piece. And that's fine, but it takes a little bit longer. So this product rule is actually a good time saver because it says I can just take the derivative of the first, okay, times the derivative, or times the second, just leaving it alone. So that's x squared plus x. And then I can take the derivative of the second, which was x squared plus x, times the first. And that was x cubed plus 2. And I started writing a little too big there. So let's shrink that down. Okay. Tidy that up. Okay, perfect. Now I can actually do the differentiation. So the derivative of x cubed plus 2, well, that'll just be 3x squared, right? When I take the derivative of 2 is 0. And then I just leave x squared plus x alone. And now I'll take the derivative of x squared plus x. So that will be 2x plus 1. And then I multiply by x cubed plus 2. That was, again, so it's derivative of the first times the second plus the derivative of the second times the first. And then if I don't need to simplify, then I'm just done. Now, if I need to simplify, then I have to distribute these terms and combine like terms and everything. But I would say if all I'm asking for you to do is differentiate, then you could be done here. But you could do an optional further step, which would be 3x squared times x squared will give me 3x to the 4th, plus 3x squared times x is 3x cubed. And then now I'm going to have to FOIL here, so I'll get 2 times x cubed is 2x to the 4th, plus, I guess first outside would be 4x, and then inside would be x cubed, and then last would be plus 2. And then I'd have to combine all the like terms, so maybe I'll highlight my x to the 4th terms, my x cubed terms, and I only have one linear term and one constant term, so this is telling me that I should have 5x to the 4th plus 3x cubed, sorry, 4x cubed, and then plus 2x, plus 4x plus 2. So that should be your final answer. Hopefully I didn't make a silly algebra mistake there. Okay, thanks for your time.